Hey everyone, welcome back. Yeah, sorry about the delay in getting these videos recorded over the past couple of weeks. I definitely meant to do more than I actually did, but it's been a busy couple of weeks, and I'm now settled in for a new term of classes at university. Hence the change in scenery in the background over there. Um, but yeah, so basically, we left off at the end of December, or at least at the end of the videos I recorded in December, um, talking about algebra, and we did some problems involving a single variable, and we did some problems involving two variables. So normally, when we were working with just one variable, we called it x, and when we were working with two variables, we called them x and y. I'm gonna have to be careful about this light here. I'm gonna try and keep the whiteboard angled so that that glare doesn't bother you guys. Maybe I'll turn my laptop brightness down a little bit as well so that the glare from that doesn't show up either. Um, but yeah, so according to my original plan for the year, um, we were going to sort of finish off December's classes, like right before the winter show, with those algebra videos that I last posted there. And I had originally planned some fun math lessons, which I didn't end up doing yet, but that's because I'm still holding out on the surprise that I mentioned a couple times before. So you should be getting some of those fun math lessons in the not too distant future, hopefully. We'll see if that works out, but whatever, we'll figure that out when the time comes for it. Um, so what I'm going to do is I'm just going to proceed with my original plan for the time being, which, of course, based on when you guys are watching the videos, will be a little bit different from when I was planning them. But what I had was, because we were working on algebra problems with one and two variables before the break, I figured we could start with a little bit of a refresher after that. So just on the off chance that you've gone ahead and watched all of those videos over the break and now you have nothing to do and you've forgotten those things, we're gonna start just two videos now. That'll be a little bit of just a little bit of a refresher, going sort of back to basics, going through the step-by-step procedure that you'll need when you're solving these questions. So if I remember correctly, it's going to be three-ish lessons that'll be more of these practice problems. So today we'll go through the breakdown for how to solve problems with one variable. We'll go through like the breakdown, and then we'll do one or two examples. In the next video, we'll do the breakdown for how to solve problems involving two variables, so x and y, and how to solve that, and then we'll also do one or two examples of that as well, time permitting. And then after that will just be one more video that's purely practice problems. So hopefully something like one or two questions for one variable, two questions for two variables, where one is just pure numbers and the other is a word problem. So one is just like pure, like I just give you an equation and you just solve for x or solve for x and y. And then the second flavor of question would be a word problem. So that's it. And that'll be it for this unit. And then you'll have a test review and your test on all of this algebra stuff before we get into a new unit. So let's review. Working with one variable. So when you're working with one variable, sorry, that light got in the way there, but I'll try and keep it out of the way now. So working with one variable, there's a couple things that you need to sort of do for every type of problem. So what I'm going to do is I'm just going to sort of list out the points, and maybe I'll put arrows as well. Leave a little bit of space up at the top here, or like underneath your title. Leave a little bit of space because we're going to fill in something there in a sec. So when you're working on, if you had a question like let's say I don't know, 3x plus 2 equals 11, something like that. Right? So if you had something like 3x plus 2 equals 11, how do we solve for x? That's the real question here. Actually, let me make it a little bit No, we'll leave it like this for now. It doesn't have to be the most complicated of examples. So the first thing that you need to do, so we'll put like a step one kind of a thing over here. So what you want is you want to get all of the variables on one side of the equation. Actually, let me move this up a little bit. I'll rewrite this up here. 3x plus 2 equals 11. I'll get rid of this here. So if that's the equation that we've started with, 3x plus 2 equals 11, then I'm going to write out what step 1 is for how to solve it, and then we'll actually do that step, and so we'll sort of solve one of these questions going down the side. So step 1 is you want to make sure that all of your variables are on one side. So variables on one side. And all of your terms with numbers, so anything that doesn't have an x in it, so up here that would be like the 2 and the 11, numbers on the other side. Doesn't matter if the variables are on the left side or the right side, as long as all the variables are together and all of the numbers are together but separate from each other. So the numbers and the variables don't mix with each other. So when you start the question, there'll be a mix of variables and numbers all over the place. You want to get all the variables on one side, all the numbers on the other side, with an equal sign in the middle. So our first step for that with this question is, well, we only have one term with variables. That's this 3x right here. So we want that 3x to be completely by itself. So that means I need to get rid of this 2 that's currently being added onto it. So to do that, I'm going to subtract 2 from the left side. Right, and that'll cancel out this plus 2 with this minus 2, those two will disappear. But if I'm subtracting 2 on the left side, I need to subtract 2 on the right side. So then in my next line, which I'm going to throw all the way down here so it's in line with this, is that it'll be just 3x on the left side is equal to 11 minus 2 on the right side. Now again, remember there's two ways you can think of it. One is the subtraction way, and the other is if it's being added on this side, you just take the 2, chuck it over to the other side of the equal sign, and switch the sign. So from addition to subtraction. All right, so now we've got at least all the variables on this side and all the numbers, all the constant terms on the other side. So our next step, step number 2, down here. Step 2 is group all of the terms together as much as possible. So so group well, normally the way you would say this is the way you'll hear it in like a Canadian middle school or high school is collect like terms. So that means now I don't like the wording of this because you won't say like terms very much outside of math class kind of context, but so I'll explain what that means. So group like terms, collect like terms. I'm just going to put a line here so we can sort of see what's going on. So collecting like terms, that means if I had 2 or 3 different terms that all had an x in them, so if I had like 3x plus 2x plus 5x plus 1 equals 10 or something, then if I'm collecting like terms, all of these things could be added together, right? They're all just certain quantities of x. If you replace the letter x here with the word like apples or something, so you have 3 apples plus 2 apples plus 5 apples, you can collect all of that together. As long as you're still talking about just apples in each of these 3 things, you can add all of those together. 3 apples plus 2 apples plus 5 apples will be 10 apples, and then you could just write it as 10 apples plus 1 equals 10, you know, whatever. The analogy sort of breaks down over there. But as long as you're talking about just x here and here and here, you can add all of those together. If you're talking about x squared or x cubed or y squared or anything like that, if you're talking about something else when you're dealing with the variables, so if this was 3x plus 2x plus 5x squared, the 3x and the 2x are still talking about the same thing, so we can add those two together, no problem. But 5x squared isn't the same, this thing over here isn't the same as what we've got over here, so we can't add those together and just, we can't add this together with all of that and pretend like that's okay. So when you're collecting like terms, if you've got multiple terms that just have an x tacked onto the end of it, go ahead and add or subtract whatever the sign tells you to do. And same thing over here, like with the numbers that we've got, 11 and 2, they don't have any x's, so we can go ahead and do that subtraction without having to worry about anything. So here, when we're collecting like terms, we only have one term that's got an x in it, so that doesn't change anything. So we've got 3x equals, and then on the other side, we've got 11 minus 2, which is 9. So then we've got 3x equals 9. Right? And then the last step, step 3 of 3, is basically solve for the missing variable. So solve, in this case, we'll say solve for x. You could say solve for the missing variable if you prefer. I'm just saying solve for x because we've only really dealt with x for most of this unit. So your last step is solve for x, so that means up here, when we've got this 3x equals 9, we want to get this so that it's just x by itself. So it's just x equals something. Now for this particular question, if we divide both of these sides by 3, then on the left side we get 3x divided by 3, those 3's disappear, and on the right side we're left with 9 divided by 3, which is 3. And so then you get that x must be equal to 3, and that would be your answer. Now there's sort of like an unofficial step 4, which is to check your answer by plugging it back into the equation that you started with. So if you plugged in x equals 3 here and you did 3 times 3 plus 2, does that still give you 11? So just do that last check at the end to make sure that your answer makes sense, because if you get an answer of 3, great, but if you get an answer of like 150, you should be able to check whether or not that's right or wrong. Right? So just plug it back into the equation that you were given at the beginning, and hopefully that'll sort itself out. One last thing, the reason I asked you to leave space up here is because you could say that there's technically a little bit of a step 0, which doesn't apply if I've just given you this equation of 3x plus 2 equals 11. But if I've given you a word problem, then it's a little bit trickier. If I've given you a word problem, you need to extract the information from the question to construct an equation, right? If I tell you that, you know, so-and-so is buying watermelons and each watermelon costs this much and find the total cost. Like, if I'm giving you a scenario, but I'm not telling you this is your unknown thing that we're representing with the letter X, that's when you got to do that whole thing with like let statements. Let X be the price of a watermelon, you know? Things like that. Then you have to build the equation for yourself and then solve it. So step 0 is construct an equation. And this is really only for word problems, but sometimes you will have to do it. So construct an equation. So this is word problems only. Word problems only. Yeah, so when you're doing word problems, you might need to build the equation from scratch and then solve it, but otherwise you'll be given the equation and then you just follow steps 1, 2, 3. In the next video, we'll talk a little bit more about the differences between how you would do this type of problem versus one where you've got 2 different variables, because then there's a couple extra steps, right? It's not really that much harder per se, it's just more steps. That's the only difference. So you still do the solving thing, it's just that once you've solved for one of the variables down here, you're not quite finished the problem. So the first few steps will look kind of the same when you're working with 2 variables. But yeah, anyway, for 1 variable problems, this is basically sort of the method that you'll follow when you're trying to solve them. So what we'll do is just real quick, we'll go through a couple of examples. We'll be a little bit slower with the second one, but for the first one, because we've done so many of these now and you guys have already graduated to working with 2 variables, we're going to sort of speed through the first one. So I'm going to erase this now. Hopefully you guys have got most of this copied down. I'll sort of erase them in the order in which I wrote them. Yeah, so we'll go through a couple of practice questions just to sort of refresh your memory and mine a little bit. I need to do a couple more of these videos before I make your test on this unit so that I remember what we've done, what we talked about, what we haven't talked about. But yeah, so let's go through a couple word problems. The first one will be short and sweet because there's no word problem involved. So problem 1, that's the Roman numerals. So this one, let's do 3x plus 50 equals 14x plus 6. All right, that's not the best 6, but plus 6. All right, that maybe looks a little bit more like a 6 now. All right, so 3x plus 50 equals 14x plus 6. So if we think back, step 1 is to get all of your variables on one side of the equal sign. Now that could be the left, could be the right. It's your choice. Now for me, I'd be okay with either, but if I bring the 14 over here, I'm going to end up having a positive 3x and a negative 14x, because right now it's positive, but when I bring it across the equal sign, it's going to be negative. I don't want to deal with negatives if I don't have to. Like, I mean, I will if you make me, but this is up to us. So I'm okay with you choosing to bring the 14x over to the left, but it's probably easier to take this 3x over to the right. So in our second line, we'll have the 14x will stay put, right? This 3x, we're subtracting from both sides. I'm taking this 3x, I'm throwing it on that side of the equal sign where it'll be subtracted, because right now it's being added to the left side. Right now it's a positive quantity. There's like a little invisible plus sign over here. So you'll notice that we still haven't dealt with this 50 and this 6. So this 50, I'm happy to leave it on this side because it's a number. There's no variable attached to it. And we're putting all the variables over on that side. So I'm happy to leave the 50 over here. But we're just going to have to make sure that we remember to bring that 6 over to this side. So I am skipping a step that we used to do this in 2 steps. One step we'd bring the 6 over, and the next step we'd take the 3x over, or the other way around. I'm just doing both in one shot. So the 3x is going over to that side, and the 6 is coming over to this side. Now, because it's positive 6 on the right, it'll be negative 6 when I bring it over to the left. So when we go ahead and solve this, so this is where step 2 comes into play. Collect like terms. So these are both numbers, so I can go ahead and do that subtraction. This has an x tacked onto the end of it. This has an x tacked onto the end of it. So I can collect those terms together right now. Now, depending on the question, if you're working on a much, much harder question, you can collect like terms all the way back at the beginning. But for the purposes of the questions that we've been doing, you can afford to leave the collecting like terms until one step later. That's fine. But yeah, steps 1 and 2 are sort of, you can switch them around as needed, which is something that you'll figure out what's best with more and more practice. You'll figure out what makes the most sense. So now, because we've got like terms over on the right side, we've got just a single variable attached to the ends of the numbers, and then over here we don't have any variables whatsoever. We can go ahead and do the subtraction. So here, 50 minus 6 gives us 44, and then over on that side we get 14 minus 3 is 11x. So we still have to keep that x attached to it, right? So it's 14x minus 3x is 11x. Now our last step is step 3. We want to solve for x. I don't want x. I don't want 11x equals something. I want x equals something. So I want to get rid of that 11. So to do that, I'm going to divide that right side by 11 so that this 11 and this 11 disappear. But if I'm dividing this side by 11, I need to divide this side by 11 as well. And so then in my last line, I'm going to get just x on that right side because the 11's disappeared. And on this side, I'm going to get 44 divided by 11, which is 4. And so then you get x is equal to 4, which if we go ahead and do that math, it should be 56 plus 6 is 62. This should be 12 plus 50 is 62. Yeah, so that should check out. X equals 4 should be the answer that you get for this one. All right, so hopefully that's making sense. We're gonna do one more. It'll be a word problem, so it'll be a little bit longer, a little bit more complicated, but not really that hard. So I'm going to start writing that out just while you finish off copying the end of this one. Hopefully your memory's been jogged if it happens to have been a while from the end of the last video to the start of this one. Maybe I won't count this as like a lesson number something. I might just title it review something, but we'll see. this just might confuse you guys if it's like, okay, working with one variable, working with two variables, and then out of the blue, a review, and then a test review. Like we'll see. I'll figure out the naming and numbering of this stuff. I'll still put it in that same playlist so that you can find this video and the next one without any issues. Of course, if you're watching this, chances are you found it in that playlist. So, yeah. So this is the second of two practice problems for this one that we're going to start now. And then in the next video, we'll review working with two variables, one similar style. So we'll go through that breakdown. We'll do one problem with just numbers and then one word problem. I just need to figure out when I'm going to record that around my classes and stuff. All right, number 2. Peter is buying gloves. Who doesn't need to buy gloves in the middle of winter here in Canada? So Peter is buying gloves. Each pair of gloves costs $12. All right. He buys I'm going to make this a little bit unusual. Normally I make you guys figure out the variable for yourselves. I'm going to give you the variable. He buys X pairs of gloves. All right, this is a little bit of an unusual question. He buys X pairs of gloves. Okay, so I've given you the variable that like your unknown quantity is this X over here. He buys X pairs of gloves. If he started, so like if he left home with $63 and has $3 left now, how many pairs of gloves did he buy? So there's a full question. We're gonna take out important bits, and then I'm gonna erase everything else so that we can make some space to actually solve it. But yeah, so here's the question. Peter is buying gloves. Each pair of gloves costs $12. He buys X pairs of gloves. Now if he left home, so if he started out with $63, and after buying all of these gloves, he's got $3 left, how many pairs of gloves did he buy? All right, so that's the question. Now you could, if you want, you could put a let statement down here. Well, I mean, look below the question that says let X equal the number of pairs of gloves that he bought. If you don't do that for this type of question, that's okay because it's been specified for you. It's X pairs of gloves. It's still good practice. So you could say let X be the number of pairs of gloves that Peter is buying. I'm going to leave it out for now just so that we can get moving on to the solution because we know that X is talking about the number of pairs of gloves in this case. So what's the important information here? We don't care about this first sentence. Peter is buying gloves. We know that. Each pair costs $12. All right, that's useful, so I'm going to write that up here. So one pair of gloves is $12. All right, one pair of gloves is $12. That's useful. We'll put we'll put X is equal to the number of pairs of gloves. I'm sort of doing this in a sideways kind of way, but it's all right. Number of pairs of gloves. You don't have to set it up exactly the way I am. I'm just sort of trying to convert the information from the word problem into a few shorter lines so that we have some space. He started with $63. Starts with $63 and has $3 left. and we want to figure out how many pairs of gloves he bought. So the number of pairs of gloves he bought is X, so basically we want to find X in this particular question. All right, so one pair of gloves is $12, great. He started with $63. This is important. So if he started with $63, here's what we know. He's got $63 has to equal whatever he bought and whatever he has left, right? Whatever it cost for him to buy all of the gloves that he got, plus whatever he has left over has to equal 63, right? Well, we know that what he has left over is $3, right? So that means it's going to be $3 plus whatever it cost him to buy the gloves has to equal 63. Does that make sense? He started out with 63 bucks. He has $3 left, which means he's spent 60, right? And we need to figure out how much he spent on a single pair of gloves. Now, here's the bit that might take a little bit of practice to get. You guys might have already figured it out, but just in case you haven't. So if a single pair of gloves costs $12, 2 pairs of gloves would cost $24, right? 3 pairs of gloves would cost $36. 10 pairs of gloves would cost $120, right? It's the cost of one pair of gloves, this price right here, this $12, times however many pairs he gets is the money he's spending on the gloves, right? So how do we write that mathematically? If we're spending this much money for each pair of gloves, and we want to figure out how many pairs of gloves we're getting, it's going to be the price times how many pairs of gloves he's buying, right? So that's going to be 12. You can put it in brackets if you want, but because of bed mass, it doesn't really matter. 12 times X, right? Now, I don't like this notation because I've put a multiplication X here and then the variable X over there. So I've written it this way just so you can sort of see what I'm doing, but I'm going to change it in just a sec. So right now what we've got is, just so you can see what's going on, this X is number of pairs of gloves, right? That's not a hashtag. Number of pairs of gloves. This is cost of one pair of gloves. That's where the 12 comes in, right? So the X is the number of pairs that we're getting. 12 is the cost for each pair. 3 is the change left over. I'll just write change. We'll assume he gave all 63 bucks to the cashier and she gave him $3 back. And 63 is the starting amount. Starting amount right there. So $63 is the starting amount, $3 is the change, $12 is the cost of one pair, and X is the number of pairs of gloves. I'm going to get rid of those numbers, of those labels now, because we need the space below it to actually solve this. But I'm also going to change the way I've written this, because I don't like having this multiplication X and that X in the same problem. Now you could rewrite the multiplication with just a dot, but I personally don't really like that either. I'm just going to write it as 12x. All right, and I'm going to move that x closer. So 3 plus 12x is equal to 63, right? So this 12x is $12 per pair times the number of pairs is going to give him the cost of all of the gloves that he bought, right? So if I want to solve for x, well, first thing I want to do is I want to get all of the numbers on one side of the equal sign. I've got the 12x over here. I'll leave the 12x over here. I'm going to throw this 3 over to the other side. Right? So then we'll get 63 minus 3 is equal to 12x. Right, which makes sense. We already know if he started with $63 and he's got $3 left now, he must have spent $60. So that's telling you that the cost of all of the gloves must have been $60. Here, if we simplify this left side, 63 minus 3 is 60 is equal to 12x. Right, which makes sense. 12x is the total cost of the gloves, and we know that that is equal to $60. If the question was asking for how much money did he spend, then it would have been a much simpler problem, but we want to know how much money did he spend, or how many pairs of gloves was he able to buy with that $60. So that's the last step, though. That's the last thing we need to figure out is what is the cost, or not what is the cost. We know the cost of a pair of gloves is $12, and we know that he spent $60 in total. So how many pairs of gloves can he get for that price? So to do that, we want to basically just solve for x. So I'm going to divide this side by 12 because I don't want the 12 stuck to it. So that 12 disappears, that 12 disappears. But if I divide this side by 12, I have to divide this side by 12. And so if you go ahead and you do that division, you'll get that x is equal to 5. 60 divided by 12 is 5. So that's where you'll get that x is equal to 5. And that should be your answer. So if you double check that by plugging it into this equation that we created, 12 times, well, if x is 5, 12 times 5 is 60, plus 3 is 63. So that should check out on both sides. And then the last thing that you could do is put a little therefore statement. Therefore, Peter bought 5 pairs of gloves. 5 pairs of gloves. Cool. I know that's really small down there, but it's just a little therefore statement. You can always put that in based on the wording of the question. You can use the exact same wording and just sub in the answer into the middle of the sentence. So not that much to it. Hopefully this is making some sense and jogging your memory if it happens to be a little while since you last saw these types of problems. But yeah, so that's it for this video. In the next one, we'll do something similar, but for problems involving 2 variables. It might be a little bit more involved in some places, or maybe we'll only do one practice example because of how long it can take to sort of get through it all. But we'll see, time permitting, with how my classes are going. We'll see if we can do one tomorrow or if I can squeeze in both of them in the next video. But yeah, if you guys have any questions, get in touch with me. I'm logged into my email all the time, so even though things are a little bit hectic, I will be notified if you guys are sending me any questions or have any doubts. But otherwise, I will see you guys in the next video. Have a good one.